Now, as we go on to topic 2, I do want to mention something from the previous section in regard to degree. Well, here we have degree of a term, which is just one of these, separated by either a positive or a negative sign, and then the degree of an expression. Now, an expression would be all of the terms, and so sometimes there's a little confusion there. So let's see if we can straighten that out. So what's the degree of a term? Well, it's the sum of the exponents on the variables within a term. So here there's a 2, there's a 1. So the degree of this term is 3. Now here there's a 3 and a 3, so the degree of this second term is a 6. Now in this third term, this is a 2, and a 4, so adding those together, the degree of that term is 8. Now, what's the degree of the expression? And here's where you probably should write this out. It is the highest degree of any one term. So here, this one's 3, this one's 6, and this one's 8. So the highest degree of any one term is 8. So the degree of this expression is 8. Now, I won't tell you what students often put for the answer, because that's wrong. This is the rule. Okay? So it's a little confusing because here we add them within a term, but for the expression, we only pick the highest of the terms. I won't say what we don't do. Don't want to put that idea in your mind. Okay, we're going to clear this up, and we're going to give you now some basic background for this lesson. And that is, when we multiply things, what are some rules? And you may know these already. Well, if you multiply a positive by a positive, and take some notes on this, the results are positive. If you multiply a negative by a negative, the results are positive. So the rule we often say is, if we multiply signs that are like signs, we always end up with a positive. And then the other is, if one is positive and one is negative, the results are always negative. So these signs are unlike. Multiplying unlike signs, the results negative. So this is a little recipe and rule for working with the signs. Now let's get on to some examples. Now I'll do the first one, and then we'll give you some classwork where you can work on some of these. Now, when we are multiplying what in essence is a monomial times a monomial, we just multiply the numbers, and then for our variables, as you recall from an earlier lesson, we just add the exponents. So this will be m to the 5th, n to the 7th. Remember, there's a 1 there that we don't write. Okay, now watch the signs too. For instance, when you have a positive times a negative, this answer will be negative. And if you figure that out ahead of time, then you don't have to worry about the signs. So negative times a positive, This will be a negative. So let's take a moment to write these out. Well, these are pretty easy, so check your work. Now in this next case, we're going to multiply a monomial, but now within a parenthesis, it will be a binomial. And we're going to use something that's called the distributive property, where we distribute the z to each of these terms within the parenthesis, and again, following our rules. So let me raise it up and give you a chance to work on it. Okay, you can check your work. Now, what I did after I did the initial multiplication is I went back and did it again, because it's so critical that you get the right signs, checking your exponent total, because it's maybe easy to make a little error somewhere. And this process is we are distributing. Now, an interesting thing that's happening here, we are going from products now to, in a sense, individual terms. And later in this unit, we're going to say, take this and factor it. That is, see if we have a common factor in each of these terms. And the common factor here would be z, that we would factor out. And in a sense, this is the results, but if we factored it, it would go back to something like that. Okay? An interesting observation. Again, it's easier to multiply, and you are challenged when you have to reverse it to factor these. Let's go on. Now here we are multiplying a binomial by a trinomial. Now there is a way to do this horizontally, but I think that leads to errors. So my suggestion, and you can still do it horizontally, my suggestion is that we set them up, all of these, vertically. So I've left a lot of room here. You're going to write this out on your other page. So let's set up this first one. 4x squared plus 9x minus 3. Now we want to multiply this by this. So we put this underneath here. We put a line here. And again, we want to indicate that we're going to be multiplying here. So we now are going to multiply a -1 by each of these terms. And basically all it does is change the signs. So this becomes a +3. This will become a -9x. And this becomes a -4x squared. Now what we're going to do is multiply this term by each of these, and we're being careful that when we get a product, we put it under our like term column. So 2x times a -3 is a -6x. Multiplying this by this and putting it under the like term column. We then go 2x times 9x. We get a +18x squared, and putting that under the like term column. Then we go 2x times this gives us a positive 8x cubed. Now that we have all our terms, we put our line, and now we just add them up. So this is going to be a plus 3. This will be a negative 15x. Now here we have to be careful. They're unlike signs. So this is a positive 14x squared. And then we just bring this down here. And again, we've done something in a neat and orderly way, developing a strategy to ensure that we're going to get correct answers. And if I were a student taking a test, I would go and double check that I copied this down correctly, and then again go through every item, watching the signs, checking everything out. You want to get a correct answer. So for example B, again we have a trinomial now multiplied by a trinomial. We're going to set it up vertically, being sure we copied everything down correctly. And you might say, which do I put on top? Well, here we put the 3 on top, the 2 on the bottom. Here it doesn't make any difference. So, for classwork now, copy this down on the other side of your booklet, and then show your work neatly and carefully, putting them in like term columns, and let's see what you get. Now, again, you would check carefully that you copied them down correctly, and then start your multiplication, watching the signs, and then being neat and orderly, having your like term columns. Now, I had a little difficulty here, so what I suggest is you add these two together. I got a negative 27a off to the side. Then I had a positive 16, and then I got this. Now, can you see where you might make an error? You have 3 times 3, 9 places here that you are multiplying. Then you have 5 places where you're adding. So there's lots of little areas where you can make an error. So take your time, neat and orderly, check your work, and if there's a little slight error in the test when you put it in MathLab, I can give partial credit because you've done all of this. Now we're going to pass up letter C because we've shown you how to do this already. Now we're going into a topic that I describe and often is described as special products. That is sort of a special way of doing things. And the first one we're going to look at is what is often referred to as the FOIL. Now the FOIL is an acronym in which the F stands for first, which in 2 sets of binomials are the first members of them. You multiply these two together. Then we have the O, which stands for the outers. This one and this one. Then we have the I, which stands for the inners of your binomials, which is this one and this one. And then we have L for the last, which is the second member of each binomial. And notice now everything is multiplied by everything. Now another way of thinking of this would be x plus 3 over x plus 4. Multiply this, and that's what the FOIL does. Now you want to know the FOIL because this is going to be a way to check many of our answers later when we have to unfoil it, as you'll see. So let's do this first one and clear it. We'll do it together and you could write it out. So x times x gives me an x squared. That's our first. Our outers give me a positive 4x. Our inners give me a positive 3x. And our last gives me a positive 12. Now notice we have 4 terms, which is what we would have expected, and our 2 middle terms are like terms. So to simplify this, we then write x squared, group our middle terms together, plus 7x plus 12. We now have a trinomial that came about from multiplying 2 binomial factors. What we'll be doing shortly, not in this lesson but later, in this section, in this module, is take this trinomial and factor it back into its factors. Now, foiling is easy, relatively speaking, because we know what we have to do. Factoring involves a certain skill of what were the factors that gave us this. So, sort of keep this in mind. All right, let's do this one. We're going to FOIL. First, 3x squared, outers, a negative 3x, inners, a positive 5x, and last, a negative 5. Grouping our like terms and simplifying, x squared plus 2x minus 5. So there's our trinomial, and then later, as we say, we'll take that and factor it back into its factors. Now, for something like this, what do you do? Well, you would FOIL 2 of them, and that's what I'm going to do right now. That gives me a y squared. Now my outers are a negative 3y. I'm going to kind of remember that up here. My inners are a positive 2y. Some of us can do this mentally, and this leaves me with just a negative y in the center. And then my last is a negative 6. So I kind of skipped that middle stage because I did my outers and my inners mentally, although I wrote them out, and now I have my trinomial that I'll now multiply by this, y plus 4. And we'll let you do that. So again, we FOIL this, checked our work, put this underneath for vertical multiplication, got my results in like term columns, And again, double checking all of this, because just some little sign error somewhere would result in an incorrect answer. And this was part of it, the FOIL. All right, let's move it up. Now another special product would be squaring a binomial. Now one way to do this would be just to take it and go x plus 4. This is written twice. X plus 4. So FOIL this would be x squared. Outers 4x, inners 4x, so middle term 8x. The last would be plus 16. Now when we do this, in a sense squaring a binomial, we end up with a trinomial that is called a perfect square trinomial. Now if you recognize that that's a perfect square trinomial, it will factor into a binomial square, which is going to be very useful later in this class. But there is a special way of doing this that again you'll need to practice and you'll want to master. But keep in mind you can always do it this way too. You want to get the right answer on a test. Now the recipe for this is square the first term. Multiply these two terms together. That gives you 4x. Now here's where we double it now, because we did it twice. Your outers and inners are the same. That's where you get the twice from. So multiply this 4x, double it, plus 8x. Square the last term. That's a perfect square trinomial. All right, let's do this one together. Square this. 9x squared. Multiply these two together. Now notice the middle sign will be negative. 6xy. Double it, 12xy. Square the last term. That will always be a positive, and in this case 4y squared. Square the first term. Multiply these two together. Negative 6xy. Double it. That's your inners and outers are the same. That's why it's doubled. And then square this. And negative times negative is always a positive. Y squared. All right, square this. A little tricky. This is going to be 4/9 x squared. Now here we're going to multiply these two together. And we know we're going to get a plus x y squared here, but now we get 2/3 and we have to double that. So multiplying 2 by 2/3 gives us 4/3. We're doubling. This gives us 2/3 x y to the third, I should say. I didn't copy that one too well. Okay, that's better. Now, we're going to double 2/3, just multiplying it by 2. So 2 times 2 is 4/3. So there's our middle term. Now we square this, and that's going to be y to the 6th. We just do our multiplication here. All right, this one was a little tricky. All right, let's going on to another special product. Now here we see that we have a t minus 7 and a t plus 7. The terms of the binomial are the same, but what is different is that one is negative and one is positive. Terms are the same, one's positive, one's negative. Well, this type of arrangement, and when we have this, these are called conjugates. So what we're doing here is multiplying conjugates, and we're going to have that in a future lesson too, a couple of times, where we multiply conjugates. Now an interesting thing happens when we multiply conjugates, and let me show it to you here. We're going to use the FOIL. We get t squared first. Our outers are a positive 7t. Our inners a negative 7t. And our last is a negative 49. Now notice what happens to our middle terms when we multiply conjugates. The middle terms just cancel out. So we're left here with just a binomial, which is a perfect square, first term, minus a perfect square, second term. So in a sense, we have what is called the difference, because of the negative sign, of perfect squares. So is that true whenever we multiply conjugates? And the answer is yes. If you recognize that these are conjugates, this one's a little different here. We'll get to that shortly. These are conjugates here. There's going to be no middle terms. It'll just be this times this and this times that. Now, since we have all these decimals here, we may need to pause to see what we get. But we know this will be an x squared, and this one's going to be a y to the fourth as we square those. So here, in a sense, we have 16 times 16, which is 256, and we need two decimal places, so there's that. And 9 times 9 is 81, and we need two decimal places, and that's that. And it's the difference now, still, of perfect squares. Now, this one's a little interesting, and it's a challenge. After all, this is college algebra. So what do we see here? Well, if we made a bracket here and a bracket there, and we put the parenthesis there and the parenthesis there, can you see you have conjugates here? So it would be then y plus 2, the quantity squared, minus 16 x squared. Now that's not the answer yet, but it's a way of looking at that. That was extremely tricky. So we expand this binomial using that technique we had up there. Square the first term, multiply these together, double it, squaring the last term, and then minus 16x squared. Okay, not too bad. So, again, if you have any questions on these, ask. Let's move it up. I recall when I first saw this, I didn't quite know what to do since it had been a while, but see if we can figure this out. Now this is a function statement, and we said the x is being replaced by something. So in this case, the x is going to be an a, and we just add 2 to it. So you can work along with me as I do some substitution. Letter A. So it'll be 3 times our x is a that we're going to square, plus 5, and x is our a, minus 9, and then we also have a plus 2 there. So this one's not too bad. So this is just going to be 3a squared plus 5a minus 7. So again, following the process, we're going to put the a where the x is and just add 2 to it. Now for letter B, our x is going to be replaced by a plus 2. So let's do that together. 3. Now our x is a plus 2, the quantity squared, plus 5 times x, that we said is a plus 2, and then just minus 9. So the first thing we have to do then is to expand this binomial. So this becomes a squared. Multiply these together, double it, plus 4a, square the 2, plus 4. And we can just write this out here now. This is going to be 5a plus 10 minus 9, and clear parentheses here. This is 3a squared plus 12a plus 12 plus 5a, and I can just do this little subtraction here. This will be a 1 to help us simplify a little bit. Now a squares, as we group like terms, 3a squared. We have this and this that are like terms, plus 17a, and then adding a 12 and a 1 gives us a 13. So again, understanding the process, we are substituting a plus 2 where the x is, and that's just what we've done. Now the next one is a little more challenging because we have to do it twice. This is going to be our first replacement of x, and then our second time we write this again, we're going to replace it with an a. So let me set that up for you. So looking at this carefully, our a plus h will replace this x right here, and I'm putting it in parentheses. Here the x is replaced with an a plus h, and we have a minus 9. Okay. Now, since there's a negative there, we put a negative, and I put brackets here because I want to replace the x now with an a, which is what I've done here and here. So now we have to kind of start to simplify. And I'll do it in parts so you can follow. So now I have to expand this binomial. So I square this first term, multiply these two together, and then double it, square this term, and I get this. Now I'm going to clear parentheses by getting 3a to the second plus 6 ah plus 3 h squared. Now I can expand this and get plus 5a plus 5h minus 9. And then here I'm going to do this internally here. This gives me 3a to the second plus 5a minus 9. Now I'm going to change each of these signs. This becomes a negative 3a squared. This becomes a negative 5a. And this becomes a positive 9. Now I have the job of combining like terms. Wow. Well, we can do this together a little bit here. So I have 3a squared with a negative 3a squared. I'm just going to cancel those out. Now I have a negative 9 and a positive 9. I have a positive 5a with a negative 5a. And now what do I have left? Well, I got rid of most things here. So I have a 6ah. I can probably put this, well, I'll put it here for now anyway, plus 3h squared plus 5h. And that's the answer. So I lucked out on this. Again, this one is super complicated, but if you want to go back and watch it again, that's why these videos are available for you as your sort of permanent reference. You want to know how to do something, and what I've tried to do is show you in some detail the protocol, the steps, the strategy for doing so. Now again, many places where you can make an error, so take your time, be neat, orderly, give it your best shot. We'll be starting on topic 2-3 shortly.